Hello, this is my English speaking practice, and I'm working on coding problems. The first problem is repeated DNA sequences. The DNA sequences is composed of a series of nucleotides, abbreviated as nucleotides abbreviated as ACGNT. For example, ACGAATTCCG is a DNA sequence where when studying DNA, it is useful to identify repeated sequences within the DNA. Given a string S that represents a DNA sequence, return all the 10-letter long sequences substring that occur more than once in a DNA molecule. You may return the answer in any order. So the example 1, the S is like this, and ten-letter long sequences that occur more than once in DNA molecules. Okay. I see. So this sequence substrings occur twice, and this occur twice. Okay. And this is occur 3 times because they are all A, so we can count 4 times. We can count 4 10 A 4 10 A's. Okay. So basically, yep, we have to use 2 pointers because we just check 10-letter long subsequences. So in this case, the left pointer point to here, and 1 2 3 4 5 6 7 8 9 10. So the initial position of a window is like this, and we can count this one. Okay, and then the window shift right, and the window is like this, and we can count these substrings. So I have to store the count, so I will use HashMap dictionary. Count is the key is the like this. Key is the substrings, and we keep track of count, and we going through the end of DNA sequence, and if the right pointer reach to the end, um, yeah, loop the loop finishes, and finally we return the key that which value is we return the key whose value is more than 1. Yep. Such that count appearance. Yep. So let's start to code. We will use left and right pointer and the left pointer is 0 and the right pointer is 10. And if the length of DNA is less than 10, we cannot find 10-letter long sequences in it, so we return empty list. This is the edge case. And we can get window by slice, and that point left and right we can get point window, and also I have to prepare a default dict and count increment the count for the key for the window, and then shift right. Yeah. Yeah, let me think. Okay. This is R. If R is equal to N, we can continue the loop because we will use slice. So if N is 10, we can check it. Okay. And so maybe we don't need to use this condition because this condition must not meet, so we can remove this. And finally, return key such that its value is more than 1. So we iterate through count its items. We get key and value, and if v is more than 1, we can append its key and return answer. Great. Okay, let's submit. Okay, I think great. Okay, let's go to the next question. Rotated array. Given an integer nums array nums, rotate the array to the right by k steps where k is non-negative. Okay. And try to come up with as many solutions as you can. There are at least 3 different ways to solve these problems. Could you do it in place with constant of 1 extra space? Okay. Okay, extra space. Yeah. 1, 2, 3, 4, 5, 6, 7. So in this example, since k is 3, so the 1 is shift right 3 times. 1, 2, 3. 1, 2, 3. Yeah. if we can use extra space more than constant extra space, we just prepare another list to store the temporal state, and we can update one by one, right? In order to solve this problem, constant extra space Let me think about this example. I'm wondering, I'm thinking about using temporal variable. So for example, in order to wait. The idea that comes first to my mind is checking one by one. So when we want to move this one, the current index is 0, so the next index gonna be 3. So the 1 is at here, and we have to store the number that is overwritten to temporal variable, and next we have to rotate this number. So the current index is 3, so the next index is 6. So the 4 gonna be here, and the temporal variable is 7, and the current index is 6, and it's the end of the list, so the 7 is come here, and next 3 is come here, and next 6 is come here, and next 2 is come here, and 5 is come here. And when we met 1, that is already moved, so we have to keep track of the first element. First num is 1, and first num is equal temp, so we can return we finish this rotation. Yeah. That makes sense. And space complexity is n, because time complexity is n, because we just move every number at once, and for each step it takes only constant time, because we can get the index and we can access it. Okay, and the space complexity is constant. Yeah, we are thinking about the solution with space complexity is 1 constant. Yeah, we just use 2 variable additionally, so this solution is this solution's space complexity is constant. Okay, it seems good. So yeah, before coding, let me think about the edge cases, but the k might be 0, and if k is 0, the first num is 1, and the temporal variable is also 1, so we just return, so this process can cover it. And when k is large, not problem, and the number of lengths is 1 to 100,000. Yeah, we can cover it. And number value of number, that's not problem. So yeah, this logic can handle all cases, I think. So let's code it. N is length of nums, and we have k as well. While first So the first num is the head of the list, and the temporary variable okay. Let me do the base case here. The first num is head of numbers, and the next index is 0 plus k. So k, okay, and the temporal variable gonna be nums next index, okay, and then the number at the next index is going to be updated to first number, or maybe we have to have current index, and that is initialized with 0, and this is either is fine. This is more intuitive, and the number is updated like this. And after that we compare first number and temp, and if it's not the same, temp should be moved to the new place because it's not it should be rotated, so the process is almost same. The current index that is next index, and the next index is current index plus k, and yeah, that's good, but next index might be greater than n. For example, when the current index is 6 plus 3 is 9, and it should 9 modulo by n, it's 6, right? Three. But since it's zero indexed, so yeah, plus 3 means 3 means index 2. Okay, is this correct? Let me think about this case. The index is 5. So 8 times 8. Yeah, seems good. So we have to update the logic here. But how about when there is no remainder? That means three. The index is 3. 6. 3 plus 3 is 6. Oh wait, n is 7. 1, 2, 3, 4, 5, 6, 7. Oh, it's long, so yeah. We just modulo. We just get remainder divided by n and get the remainder. That would be the next index, right? And yeah, and if the temporal value is same to first number, we finish the main logic and return finish logic. That's all. Let me run it. Wrong answer? Something wrong. Why? Current index and next index, and store the number at next index. We update the place at next index. The current index gonna be next index, and next index gonna be current index plus. I see. Next index. No. 4736251. Great. I see. We have to update the place at the next index, and yeah, when we in the loop maybe this is here. When it's not the same, we update the no, something wrong. We have current index and next index, and we have to update the place at next index, but in order to avoid to overwrite the number, we have to store the value at next index, so temp. After that, we can update next index. Okay, and we have temporal value. That is the and current index. Yeah, current index. From the current index, we can find the next index, and I see. So we have to let me think about temp2. Because next index should be updated by temp, that is previous temporal value, and when we update the new next index at the number at new next index, we also escape that number at the next index. So that is temp2. Okay, and temp is updated to temp2 because temp is used for the next step. Okay, so we don't prepare this like this. I see. It's not always the cycle made by all of elements. In this example, the cycle is -1 and 3. -1 is moved to here and 3 is moved to here, and that's all. So yeah, in my current implementation cannot handle this case. So the problem is k is 2 and the divider is 4. So I'm not sure. I'd like to see the solution with time space complexity is constant. Reverse. Okay. Yeah. This is not constant space complexity because reversed function okay, but the basic idea is reverse at first and specify the k. Makes sense. So this means reverse at first, so 7 6 5 4 3 2 1, and we can find the boundary. K is 3, so we can identify the boundary, and 7 6 5 gonna be 5 6 7. We have to reverse for this part and also reverse for this part. That's all. So yeah, my solution is make it complicated than it should be, because yeah, we have to keep track of where we already updated or not. So in this case, every number consists of the cycle to rotate them, but in this case the cycle consists of -1 and 3. So when we update 3 and -1, the process will finish, so we cannot find these numbers. Yeah, so in order to avoid this, we have to keep track of where we already updated, and that makes it more complicated, so I shouldn't use this. So the basic idea here is find the boundary and how to shift them based on the boundary. In order to do it in place, we have to implement reverse function by myself, because the Python's built-in reversed function need extra memory, so the size is 3 and 5. Size gonna be 3, and the range is 1, so we loop once, means 5, 4, 3. And when there is even values, the size is 4. We loop twice. Yeah, correct. So this function is good because this is in place function, so this function can modify the list itself in place. Okay, so we can use this, but for update, partially, we use custom reverse function, and this and include inclusive range, so the k minus 1 and yeah. Correct. Correct. Let me use custom reverse function at first. Okay, the memory is improved. Memory usage is improved. Okay, great. So let's go to the next. Today's goal is solve to 85. So 5 problems to solve. Bitwise and of numbers range. Given two integers left and right that represents the range left right. Return the bitwise and of all numbers in this range inclusive. I cannot understand this bitwise and of all numbers in this range. Bitwise. So what I understand is we just how do I say, we just do AND operation for each numbers in this range. So like this. Oh, but the value would be so large, so I think time limit exceeded. Yeah, makes sense. But the problem, what the problem is saying is like this. So we have to do the bitwise end of all numbers in this range. Means like this. Okay. So the problem is how to reduce the calculation. Yeah, bitwise. Okay. So end. So if there is 0, the digit won't be going to be 1, because if there is at least if there is 0 at least once, that must become 0. So I think that means two. If there is 2, that means the first digit must be 0, and if there is 4, the first and second digit must be 0. Okay. So let me think about 5, 6, and 7, and we have to think about the even numbers, because the 6 is 4 plus 2, so like this. Okay. And for 5 it's like this. Okay. So in this case, the answer is 4. And when we think about two big numbers, it's like this. yeah, we don't know the bit, but we can know the leftmost bit is 1. And when we think about the smaller values, it's gonna be 0, 0, 0, 0, 0, 0, 0, 0. For example, 5 is like this. So this part would be 0 because there is 0. So we don't think about right. Yeah. So it depends on left value. So in this case, the 8 is like this, but there is 5, so the 8 is I see. And when we get 8, it means these 3 digits are all 0, so this part would be 0. Okay. And also when we think about more than 7, it's they have more than 3 digits, but as long as there are 3-digit numbers, the left part would be 0, so it's 0. So the challenge here is we can get left value, and we have to calculate the next number that has the digit that has the one more digit, right? Does it make sense? So I want to say we have to look for the number that is 2 power of n, and we have to find the number that 2 power of n, and that is we have to find the range that is specified by the number that is 2 power of n, and the left number within the range. Okay, and so if the right number within the range as well, we can find not 0 result. But if the right number is over than the range, that means over the 2 power of n number, that means the right number has the 2 power of n number has all zeros, and also for the right number, for the right numbers, leftmost digit is 1, but there must be the smaller number, and the smaller number has 0 at the digit. So so overall the result would be 0. Okay, So I want to so the range we have to find 2 power of n, and the left is located at 4 between 4 and 8. So check if mm. 5 to right numbers, and otherwise it must be 0, because as you can see, the 2 power of n has zeros. So in this case, the 8 make it zeros for smaller values, and for the numbers more than 8, they become 0 because there is a smaller number, right? Yep. So let me code it. And before coding, let me think about edge cases. If the left is 0, it must be 0 because 0 is all zeros. So we think yeah, and we have to no. As long as 2 pole is left or less, we can identify, we can going up. And if 2 pole is more than left, we break it, and if right is smaller than 2 pole, oh, why I remove the logic and is this correct? Because when we think about the left is 1 and 2 pole is start with 1 and 2 pole is gonna be 2 and break it. The 2 pole is 2, okay? When the right is also 1, so that means left and right is 1, it should return 1, okay? Yeah, return 1, okay. And the right is 2. When the left is 1 and the right is 2, it's gonna be 0. Correct. Yeah. So it seems good. Great. Let me see the result. It takes time. Really? This part, maybe this part takes a lot of time. When the left is too big, the 2 pole is also big, but the right, so the right value is also big, but it within the 2 pole, so we have to iterate through the long range, so this is not good. So I can reduce the calculation here. For example, in this case, the 2 pole is like this. And the right is also big, but it's within within 2 poles, right? And left is also big. The previous 2 pole must be like this, so the left is, for example, left might be like this, the right might be like this. Okay. I see. So the certain information is the leftmost bit is gonna be 1. Yeah, because it's in the same range, so leftmost is 1. Oh, I see. And basically other part would be 0 because I'm not sure because but right minus 1 would be like this, and minus 1 like this, and minus 1 like this. So we have to look at the digit from the left, and as long as they are the same, they remains 1. But when we look at 0, the right part should be 0 because every digit must become 0 at once. Because, for example, in this case, this 2 digit is 1, it must be 1. And how about this part? In order to make this digit 1, the minimum value would be like this, so the other part should be 0. So So the base value is like this, and we can add this, and also we are checking we check every digit, and oh wait, we also have to write digit, but how to no, the right must be greater than left, so if the left digit is 1, the right digit is 1, so we just check for left. Time limit exceeded. Hmm? Ah. I sorry. I have to left minus. Correct. This is not cool. I want to. I believe there is a way to solve solve it in a simpler way. So let me explain. Let me submit it. Oh, really? But why? Expected is I see. 1101. Okay. How about just bitwise and up, right and left? Okay. I It's not good. Okay, I see. So to do that. Find one by one. So find one by one. If left is greater than temp, the right is true, because the left is less than right, and and when the left is oh wait, maybe we have to check it. That means both of bits are 1, and otherwise this case is also continue to this process. It means the both of bits are 0, so this case we just continue to the next step. So the temp is shift right, and otherwise it means the bit is different, so we have to finish the loop, break. Oh, wait. What? Two pole is this one. So the first temp is this one. Yeah. And we have to oh yeah, makes sense. Let me see the result. Not bad. Let me explain this code. So we think about the case like this. So basically the basic idea is this. This is simple example. The 2 power of n number is the key. In this case, the 8 is the 2 power of 3, and the bit is like this 1000. So it means the smaller numbers, the numbers are smaller than 8. It's gonna be zeros because the 8 has 3 zeros. Okay. So we have to identify the range of 2 power of n numbers. So when the left is 5, we have to find 8. Okay, and if the right value is less than 8, we can, we have to bitwise AND of all numbers 5 to right. Okay, and otherwise we can return 0 because the range contains 8. Okay, so this part would be 0 and this part would be 0, so we can return 0. Yeah, so we have to think about the case when the range is between the 2 power of n and 2 power of n minus 1. So this is the example. Okay. So 2 power of n number, 2 pole, is like this at first. So first, to identify this digit, we just divide by 2, and the temp is like this. So I think this is temp. Okay. The first temp is point to this. Okay. So the result would be temp because we can, we make sure that this bit is definitely 1, so we can add the temp value to the result, and at the same time we have to remove it because we want to think about the next digit, so we want to make this bit to 0, and after that we update the temp value like this. So the temp would be like this, and we can think about this digit, and we do the same thing like this. And there is 2 patterns to continue to this loop. For the both digits are the 1, it means the left is greater than temp value and the right is also greater than temp value. In this case, we can add the temp value to the result and move on to the next step. And the other case is like this: left is less than temp and right is less than temp. Yeah, this case is like this: the both bits are the 0 and the temp point to here, right? In this case, we can continue the next loop because it still it still can add the value. So we don't update result and left and right, but the temp is moved on to the next. So the temp is like this, okay? And yeah, that's all. And we return result. Yeah, and if they are not meet these conditions, we break it because the other part must be 0. Because for example, right is greater than left, so this situation must not come. The right is always greater than left, so when the bit is different, this situation might happen. And let me think. And in this case, the number like this must be between left and right. So that means this part would be 0, okay, and left has 0 at this digit. So if the bit is different, the remaining bit digit must be 0. So yeah, we have two conditions. We have to check the digit is same, all 1 or all 0. Yeah, if the digit is different bit, we can break it and return result. That's it. Time complexity. Time complexity is this loop is decided by the value of temp, and the temp is divided by 2 every time, so it's a log n, and also this part to be log n. So and the value is 2 power of 31 at most, so the loop happens 31 times at the most, so it's a constant time complexity, or for more accurate, log n, log 2 power of 31, that will be 31, so it's constant. And space complexity is we just sum variables, so obviously constant space. Okay. Yeah, I feel like I can simplify this solution, but I didn't. Come up with, but they shift right, left and right values, and count it. If they are different, count it. If they are same, the count stopped. I see. This is so smart. Okay, but not bad. 4 problems to solve. Count primes. Given an integer n, return the number of prime numbers that are strictly less than n. Prime numbers, okay. Prime numbers, okay. So basically, we iterate through numbers until n. We iterate through until n, and we have to remove it. We have to remove the multiples. We have to remove the multiples. So when we look at 2, 4, 6 are removed, and the next comes 3. 6 is already removed. 9, 12 is already removed. 15, and 4 is already removed. 5 comes. 5, 10, 12, 10, 15, 20, 55, 25, 30, 35, like that. The problem is how to implement this, I think. I forget the syntax. X in X range 2 to n plus 1 if X for range 4x in range if X, if not X in. So we prepare multiples its set and multiples are modified while iterating through this. Is it possible? I'm not sure, but yep. Let me try. If I am this never happened. So we have to count it and start with I. It iterates until n plus 1 and it increases by I. Okay, so multiples or anyway, let me try. Wrong answer. How about this? If multiples x. Really? I know. I knew it. Okay. But the time complexity is not good. Let me see the solution. How to implement. What it is. But almost the same, I believe. The space complexity would be n, and maybe this part is when the n is 10, until n, this is until n less than n. I see. So n and 0 and 1 is false. Don't need Is this okay. So let me write a comment. We have to explain this. Mm-hmm. Root of n. Mm-hmm. Mm-hmm. Numbers after middle cannot update prime array with their multiples. Yep. root n points to the middle of the iteration, so the number of the middle cannot update primes array with their multiples, so we don't need to do this. Yep. What is time complexity? N log n. This means n. Yep. And this part log n. Log n. I don't know. Let me have it reviewed. Ship of Eratosthenes. Obviously not prime. Iterate from 2 up to root n, because we'll mark all multiples of each number before. After root n, we don't need to continue, those multiples are already covered. Root n marks the midpoint of this process, and numbers greater than root n cannot find new multiples to mark. Yeah. Initialize a list marking all numbers as true, potentially prime. 0 and 1 are obviously not prime. We only need to check up to root n. Why? Because if a number has a factor greater than root n, the other factor must be smaller than root n. We already handled that case. Visualization is like this. We mark multiples. Once we pass root n, all composites are already marked. Mark all multiples of I as non-prime. Count how many numbers are still marked as prime. Okay, good. And three problems to solve. 1, 2, 3. Let me see. Minimum size subarray sum. Okay. Given an array of positive integers, nums, and a positive integer target, return the minimum length of subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. Subarray is a contiguous non-empty sequence of elements within an array. Contiguous, okay, and we have to return the minimum length. So let me take a look at example 1. The target is 7 and the num is like this. I see. Yeah, 4, 3 is the minimum subarray to add up to the target 7. Yep, the subarray for 3 has the minimum length under the problem constraint. The target is 4, we can get target is 11. We return 0 because there is no such subarray. Okay, and the target might be large. The length is 100 thousandths. For each value ranges from 1 to 10,000. If you have figured out the ON solution, try coding another solution of which the time complexity is n log n. Why make it worse? I'm not sure. Yep. Basically, we will use 2 pointer to determine the window. For example, it starts with 0 and 1. It starts with 0 and 0. It points to the same position, and yeah, the window, we have to keep track of sum of windows, and 2 is less than 7. We extend the window to the right, so the right pointer points to the 3, so we can add 3 to the current sum, and that is still less than 7, so extend window, and sum is 6, still less than 7. And when we look at 2 here, the sum is 8, so we can find the subarray that meets condition, and the minimum length is 4 at the time. So in this case, we don't need to extend the window, so we try to shrink the window. So the left pointer move forward, and we subtract 2 from the current sum, and that would be 6, and 6 is less than the 7, so we extend to right, and that would be 10. 10 is good, so we can shrink the window, and 7 is also good, and the minimum window size is updated to 3. And we can still shrink the window. Okay, and check if the window sum is greater than 7, but it's 6, so it's less than 7, so we have to go right, and it's gonna be 9. 9 is good, so yeah, try to update the minimum size of window, but 3, still 3. And finally we can shrink the window, and that is 7, and we can update the minimum window size, and then we are trying to shrink, and that would be 3, just 3, and that's not good, so we have to go next, but it's out of the range, so finish the process. Yeah, it seems good. So let's code it. Left and right pointer is initialized with 0, and until the right pointer, as long as right pointer less than length of num, it's valid, so we have to check it. And the current sum is num is 0, and the nums is nums is not empty list, so this is valid. We don't need to handle edge cases, and current sum is like this, and when current sum is updated, we want to check it. If and current left and right, okay, the current sum target current sum is target or greater or more, so we can update the answer plus 1 answer will be updated r minus left index plus 1. Okay, this is the window size. And for next, if left index is less than right index and the current sum is greater than target, we want to try to shrink means current sum will be reduced number at the left, and left is incremented, and yeah, still meets condition. We can update the answer. After that, we are going to increment right pointer and oh wait, hmm. Okay, if I wanted to avoid the duplicate condition, I didn't come up with a simple solution, so I will go with this. Current sum is added, it's nums at R, and it might be update answer. Yep, and return answer. Wrong answer. Ah, I see. Okay. I want to make it simple. So this while loop assures R is less than nums. length of nums. So r plus 1 must be at the end of the loop. So it's like this, and we can remove this, and so it assure R can be used for indexing numbers. Yep. The current sum is audit. Not bad. Should be initialized. Okay, let me try. Test code, test cases. Great. Not bad. And I explained the logic here, so good. Yeah, 2 problems remaining. Course schedule 2. Okay. There are total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites at I is AI to BI indicates that you must take course B first if you want to take course A. For example, the pair 01 indicates that to take course 0, you have to first take course 1. Return the ordering of courses you should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. Return the ordering of courses you should take to finish all courses. Now courses you have to take. So in this case, I have to take 2 courses, and the prerequisites is like this. So in order to take course 1, I have to take course 0 at first. So I take 0 and 1. Yeah, we can take 2 courses, so output is 0, 1. Okay, and num courses is 4 and prerequisites like this. So in this case, if we take course 0 at first, the 1 and 2 is enabled to take, so able to take, and then 1, 2, take 1 and take 2, the 3 can be available. So 0, 2, 1, 3 or 0, 1, 2, 3 makes sense. I see. I see. Okay, let me think about this example. And basically we have to sort by the second element, because this is dependent, this is dependent, so we have to take the second one. Okay. And we have to return the order as a list of integer. So we sort it and take it. I see. So every course might have a condition to take. In this case, one, in order to take one, should take 0. So 3 is a good example. In order to take 3, the 1 and 2 is necessary. So first of all, I want to make dictionary like this. Because the key is the course number and the value is its dependent. Okay, and if there is no dependent, we can take of it. And after that should be set. This value should be set, and course and dependency. And also I want to update these data structures. So when we take course 0, we want to know about its dependent, right? I don't know the meaning of English dependency dependent dependency. Oh? Dependent. Yeah. Dependency. In this case, dependency is the right side. Yes, correct. Dependency is correct. So the dependent are 1 and 2, and its dependency is 0. Yes, correct. And so we prepare 2 data structures. And if there is no dependency, we can take it. And we iterate through prerequisites at first, and we make the 2 data structures, and then we are going to iterate through the available courses. But how can we know which is the available course? When we initialize this data structure, we can know that there is a course without dependency, so we can put it some queue. The queue append and pop left. And while there is available course, we can process it. So take the course and update the dependency, and if the course get no dependency, we can make it available. Okay, and when we take the course, we have to update dependency, but we don't know which one should be updated, but we can use it. So when we take the course 0, the dependent is 1 and 2, so we can update the 1 and 2, and yeah, the course 0 should be removed from dependency because we took the course 0. So the time complexity would be we iterate through each item once. When we get the course, to update the dependency, the operation can be executed in constant time, so it's n, and we have 2 data structures, and that has keys whose length is the course, number of courses. Number of courses is 2000 and pre-acquisition is space complexity is num courses, so num courses but they are, how can we estimate the space complexity? There's a key and dependent. Num courses. Oh, I see. Oh, I see. Prerequisites. This equation comes from this, and SC space complexity is num courses, I think. So that would be n. So the first loop is iterate through prerequisites. So prerequisite exits dependency. The key is first one and dependency is the right one. Okay, and dependent key would be right one. And the value is a list of independents. Yep, we can initialize the two data structures, and we want to update deck dependency, right? Dependency items and size. I'm not sure if the size is 0. The queue appends a key and as long as there is available courses, we can process it. So take the course, pop left, and take the course C, right? And if take the course C, have to update dependent C. For example, 1 and 2 come here, and update dependency dep remove C, right? And after that, if it doesn't have dependency at all, we can append its course to available queues. Finally, no. If the length of courses is less than num courses, we still going to take course. So it's like this. And if still less than num courses, we cannot. What is it? Return empty. Is this correct? Oh, there is no requisites. I see. Maybe if there is no requisites, we cannot any of we cannot any dependency and dependent. So the problem is initialization of available courses. So it's range num courses. This is correct, and this is a course ID, and we have to look at dependency course. Correct. Let me see. Has no attribute size. It's same. I'm confused. Good. Let me see the result. Oh, good. Great. And I think I explained the code well, so finish. But let me see the but I don't think almost same. Mm-hmm. We just it was enough just to keep track of the length of dependency, because if it's 0 we just add it. Exactly. Okay. And last one. Oh, it's different type of problem. Design a data structure that supports adding new words and finding if a string matches any previously added string. Implement a word dictionary class. Word dictionary initialize the object and add the word function as word to the data structure. It can be matched later. And search returns true if there is any string in the data structure that matches word, or false otherwise. Word may contain dots where dot can be matched with any letter. Okay. Interesting. So basically we have to store it. Have to store words. And how to store the words? At the most 2 dots in word for such queries. Okay. Yeah, difficult, seems difficult, and I'm trying to figure out how to store the words. And yeah, what is the best way to store the words for searching it? But there is no constraints about space and runtime, so there is no clue. Key. Let me think about hash map. Oh, okay. The word consists of lower English letters, so the dot represents 26 characters. Not represents. Dot. So all we have to do is check all possibilities when we get dot. For example, this case, we have to check AAD to ZAD. It's 26 pattern at most. So, and the dot appears twice at most. So, we can it will be 26 times 26. It's like 500 or like that. So I think this is not bad. So the so the data structure to store words is set. We can add word and have to find we are going through word and find let me see if find the first occurrence of specified body. Find start end. Find the body start end. Okay. Find start. means 1 dot. Two dot. Okay. So we check (26) 0 to 26. The new character C gonna be char function I plus order A is the offset and I is 0 to 26 25 and the index the new word, so the new word, new word gonna be, the word index is updated. The character in the word at index I, index edx, the character is C, and we can get the new word in place. And if the word in self set, return to do immediately, and otherwise we continue the loop, and after that return false, right? And if there is 2 dots, we have to update 2 place like this. And if the word is in the set, we return true. That's it. Find is not defined really. TX defined. Okay. String object not support item assignment. Really? So we have to convert it to list of character. Unhashable type list. Wrong answer. False. Why? What? I see. We just want to make it list of characters. Okay, got it. Correct. Let me submit. But it's not fast. Oh, but the memory is so good. Memory usage is very good. is the most popular? Oh, really? Try node. Ah, I see. If the character is dot, we are going to the next. Try node have children and is finished flag. Is children. When we add word, makes sense. Okay. I think this is the expected answer. Using try node and DFS to search the word. Yeah, but I completed the problems to solve this week, so yep. So it's time to finish.